today we're going to be talking about 4.3, which is proving lines are parallel. So you need to go ahead and label page 40 and 41, 4.3, proving lines are parallel. Once you do that, you need to tear out page 185 from your textbook. So here's 40, 41, tear out page 185 from your textbook. 185. It looks like this. We're going to write on it first. Okay. Yesterday we talked about the theorems, corresponding angles, alternate interior angles, same side interior angles. We also talked about alternate exterior angles, but we're not going to do that as much today. What we are going to talk about is how to actually prove that lines are parallel. Okay. So in order to do that, we're going to form some converses. You form a converse of a theorem, which is the if-then statement. If P, then Q, by swapping P and Q. So yesterday it was if parallel lines are cut by a transversal, then corresponding angles are congruent, or whatever else. So today, converse means we swap those. So we say if corresponding angles are congruent, then then you have parallel lines cut by a transversal. Okay. In order to do that and to talk about the converses, we are going to name some relationships here. We are told L and M are parallel, so I'll highlight those in green, and they're cut by this transversal T. Okay, we are going to have to set up the three angle relationships I had yesterday, such as alternate interior, same side interior, and corresponding angles. So that's what this chart is going to be for, and then we'll use them for A, B, C, and D. Okay, so let's think about angle 4. Angle 4 is congruent to what? Well, it's congruent to 8, and it's congruent to 6. 4 and 8 are corresponding, so it might be that 8 goes here, and 4 and 6 are alternate interior, so it could be that 6 goes here. We'll see. We have to have all three, so 4 could either be alternate interior or corresponding. Let's move on and see about 6 then. 6 right here has to be supplementary to something. Oh, probably 3 then. Here's why it's 3. 3 and 6 are supplementary, so they have to be, the only supplementary one we have is same side interior. So 3 and 6 are supplementary. All right, then let's talk about 7. Here's 7. Okay, 7. Well, it can't be the alternate interior because it's on interior, so it's got to be 7 and 3. Okay, that means 4 needs to be alternate interior, so it's 4 and 6. Now, you're not going to have to figure that out on your own. This is just what we needed to know in order to actually fill these out down here. So let's look at A, B, C, and D. A says, use 2 of the given statements together to complete a statement about the diagram using the same side interior angles postulate. Same side interior angles. Well, this one is the one that's same side interior. If L is parallel to M, then 6 and 3 are supplementary. That's a big blank because they would want you to write if L is parallel to M, but that's what this means. Okay, now let's talk about how to write the converse. This is what we had yesterday. The postulate said if L is parallel to M, then 6 and 3 are supplementary. The converse is flipping it, meaning, I'm going to take highlighters again, meaning this will go here. So I take the then and put it at if. If angle 6 and angle 3 are supplementary, then, and I put the if statement, L is parallel to M. That is how we are going to prove that lines are parallel. If they have this relationship, one of these three, corresponding same side interior, alternate interior, then the lines are going to be parallel. So let's look at C and let's do the same thing. Alternate interior angles theorem. Which ones are alternate interior? 4 and 6. By the theorem, if L is parallel to M, then 4 is congruent to 6. Now, you pause the video and write the converse. The converse. The if statement comes from the then. So if angle 4 is congruent to angle 6, then the then statement comes from the if, because you are swapping them. So if angle 4 is congruent to angle 6, then L is parallel to M. Alright, pause the video, try D. Write the theorem and then write the converse. Alright, D. Use the diagram and the given statement to illustrate the corresponding angles theorem. If the lines are parallel, then 3 is congruent to 7. Reversing that, if angle 3 is congruent to angle 7, then L is parallel to M. So we're going to talk about how to actually prove that lines are parallel today. Cut from the word explore to letter D, and we're going to leave that in your notebook. So from the word explore to letter D, goes on page 40. And then we're going to do the foldable. Okay. So in this, underneath this video, there is a foldable. Remember, if you don't have a printer, that's fine. Just write what we're writing down on page 41. Okay. All right. So we are going to start. Here are the postulates and theorems, the converses that we just talked about. Okay. So the converse of the same side interior angles postulate says, if two lines are cut by transversal, so that a pair of same side interior angles are supplementary, then the lines are parallel. That's what we just talked about. Converse the alternate interior angles theorem. If two lines are cut by transversal, so that any pair of alternate interior angles are congruent, then the lines are parallel. Converse the corresponding angles theorem. If two lines are cut by transversal, so that any pair of corresponding angles are congruent, then the lines are parallel. These three are what we are going to use today. So make a nice little note right here. These are what we're using today to prove that lines are parallel. Okay, so let's look at some of these. Example 1. A mosaic designer is using quadrilateral shaped colored tiles to make an ornamental design. I cannot read today, evidently. Each tile is congruent to the one shown here. The designer uses the colored tile to create the pattern shown here. Use the values of the marked angles to show that the two lines L1 and L2 are parallel. All right, we are going to try to show that these two are parallel. There is something missing here. There should be a line here, but it didn't print. It's right here, so draw that right there. We are trying to show that L1 and L2 are actually parallel. We're not going to do a full-blown proof here, but we are going to kind of prove and talk about it. So here's what we got. 1 is actually 120. 2 is 60. Okay. We're trying to show that L1 is parallel to L2. Well, what relationship is going on between 120 angle 1 and angle 2? I think that's the same side interior angles postulate. Okay, so since angle 1 and angle 2 are supplementary, and same side interior angles, L1 is parallel to L2. So that's what I'm trying to do. Yes, it will be a sentence, and the reason is by the converse of the same side interior angles postulated. I'm writing sentences to explain why they are parallel. Okay, there's my sentence. We're going to do 4 and 5 the same way. I'm going to go ahead and highlight. Here's my transversal. Okay. 1 and 2. Here's 1, here's 2. What type of angles are those? That's the first thing you have to decide. These are 120 and 120 because I'm looking at this picture. 120, 120, those are alternate interior, and they are congruent. So since angle 1 is congruent to angle 2, and are, should have said and they are, and are alternate interior angles, L1 is parallel to L2 by the converse of the alternate interior angles theorem. You have to say converse of because you're proving they're parallel, not that the angles are congruent or whatever. All right, number 5. Pause the video, try that on your own. Yes, you are writing a sentence of some sort. I first notice the relationship, write down the relationship, the angles, and if they're congruent or supplementary, say they're parallel, and the reason they are parallel. So go ahead and do number 5. Okay, number 5. So this one is 60. This one is 120. They are same side interior, so it's actually just like this one here. So since angle 1 and angle 2 are supplementary, I ran out of room, and same side interior angles, the lines are parallel, so L1 is parallel to L2 by the converse of the same side interior angles postulate. You didn't know that geometry was English class, did you? It's just proving. That's what we're proving. We're not actually doing a full-blown proof. We will later, but that's not what we're doing. All right, so go ahead and get that. Pause the video if you need to. We're going to open this up and talk about some more of these. On the inside of this, we have constructing parallel lines. We are going to do constructions on Monday, so we're not doing this today. We will do that on Monday. I was trying to think about if it's Monday or not. Whenever the next lesson is, that's when we'll do that. All right, so let's go ahead and skip ahead to this part. So example 3, or explain 3, says using parallel angle pair relationships to verify that lines are parallel. We're still proving, it's just we don't have any formal proofs yet. It says use the given angle relationships to decide whether the lines are in fact parallel and explain your reasoning. So I'm using this diagram. I don't know if these are parallel, but I'm hoping they are. So I'm going to highlight what I think should be parallel and the transversal. I'm going to go ahead and highlight number 8 and 9 too, just to be sure. So highlight what I think should be parallel and the transversal, so don't get confused there. All right. This one's already done for us. This is step 1, identify the relationship. That's what we did on the front. Step 2, say if they are or not. We are doing the exact same thing we did right here. And I know you're tired of writing it, but oh well. So this one's already done for us. We're going to skip to B. Letter B says the measure of angle 4 right here is x plus 20. The measure of angle 8 is 2x plus 5. And x is 15. So we're going to have to plug in and make sure that actually works out, first of all. All right, so x plus 20, which is just 15 plus 20, is 35. So this is actually 35. Okay, and then 2x plus 5, 2 times 15 plus 5 is 30 plus 5, which is 35. So that does work out. Okay, now let's talk about their relationship. 4 and 8 are corresponding angles. So since 4 and 8 are congruent, they are, and are corresponding angles, L is parallel to M by the converse of the corresponding angles theorem. Okay, there we go. All right, 8 and 9. We're going to do the same thing, guys. So you need to, I don't have enough room to write right there. 8, 9. Pause the video, decide if they are parallel or not, and then tell why. Same thing that we've been doing the whole time. All right, number 8. 3 and 6. 3 and 6 are same side interior. They are supplementary, so that's fine. Since angle 3 and angle 6 are supplementary, and same side interior, angles L is parallel to M, is that right? L, M, yes. By the converse of the same side interior angles postulate. Okay. Hope you did number 8. If you didn't, pause it now and do not number 8, number 9. If you did number 9, great. If you did not, pause it and do number 9. All right, 2 and 6 are congruent. 2 and 6 are corresponding, so they should be congruent. So since 2 and 6 are congruent and are corresponding angles, L is parallel to M by the converse of the corresponding angles theorem. So today you're proving a little bit. It's just sentences, not actual full proofs, okay? We will do this on the left, the constructions, the next time. In the part 2 video, it might not be called something else. It'll be called parallel and perpendicular constructions. But all right, so glue this in on page 41. We will come back and finish it. And I will see you next time. Just do whatever the homework is. There's one of them you need to omit because it's got a construction in it, so don't do that one, okay?